A strange new object has been spotted hurtling through the solar system, positioned directly between the interstellar visitor 3I Atlas and Earth. This is C 2025 V1 Borisov, discovered around November 3rd by Gennady Borisov from Crimea, the same observer who first spotted 2I Borisov, the second interstellar object ever observed. The discovery marks another milestone in our detection of objects from beyond our solar system, and its peculiar characteristics are already challenging our understanding of what these cosmic visitors should look like. What makes this discovery particularly unusual is that Borisov appears to have no tail, or only a faint one, visible in just 2 of the last 10 observations. The object is currently closer to the Sun than 3I Atlas, yet shows none of the typical cometary activity expected from such proximity. Most observations show only a cloud of smoke rather than the distinctive tail that characterizes most comets passing through the inner solar system. The timing and positioning of this discovery have captured astronomers' attention worldwide. From Earth's perspective on November 6th, the 3 celestial bodies appear remarkably close together in the night sky, creating an arrangement that has researchers examining whether this is pure coincidence or something more significant. 2 days later, on November 8th, they achieved near-perfect alignment, a phenomenon that has both professional and amateur astronomers turning their instruments toward this region of space. The constellation positions tell an intriguing story. 3I Atlas currently occupies the constellation Virgo, while Borisov sits right next to it in the same constellation, creating what appears from Earth as an extremely close pairing. Meanwhile, C 2025 K1 Atlas has positioned itself in the neighboring constellation Leo. Together, these 3 objects form what astronomers are calling a special triangle of space between the constellations Virgo and Leo, an area currently experiencing dense and surprising astronomical activity. This K1 Atlas presents its own set of mysteries that deepen the puzzle. Unlike the other 2 objects, it displays a glowing tail, but one that radiates a brilliant golden glow instead of the typical blue or white coloration seen in most comets. This unusual coloration has spectroscopists working to understand what chemical composition could produce such a distinctive golden appearance, as it differs significantly from the standard emission spectra observed in typical cometary tails. And searching under this identifier in astronomical databases may yield more extensive data than searching for the official name, at least until various astronomical agencies update their records. This naming convention follows standard procedures for newly discovered objects, where provisional designations are used until orbital parameters are firmly established and official names are assigned. According to precise calculations based on multiple observations, Borisov will reach perihelion, its closest approach to the Sun, on November 16th. At that specific moment, it will be very close to the Sun, but positioned higher than the ecliptic plane, the imaginary plane in which most planets orbit. The geometry of this approach is particularly striking, as Borisov will almost form a perfect straight line with Earth at perihelion. Even more remarkably, 3I Atlas will also appear in a corresponding position at that same moment, making these 3 celestial bodies seem to blend into what some researchers describe as a magical axis of light. The phenomenon of alignment between Earth, Borisov, and 3I Atlas is attracting special attention from astronomers at major observatories around the world. Some scientists consider this a mathematical coincidence, a chance arrangement that occurs simply due to the random nature of orbital mechanics. Others are inclined to explore the possibility that this represents a mysterious cosmic signal, possibly containing information or patterns that humanity has never discovered. The debate continues in academic circles about whether this is just a coincidence of orbits or a subtle reminder from the universe of an upcoming event that we don't yet understand. China has finally released images of 3I Atlas taken by the Tianwen probe while it was orbiting Mars in early October. The release came after weeks of speculation and unofficial leaks about what the Chinese space program had observed. The images show a faint bright spot moving behind a dark area, believed to be the interstellar object making its way through our solar system. However, the resolution is extremely low, disappointing many experts who had hoped for clearer data from the advanced instruments aboard Tianwen. The quality of the Chinese images has become a topic of heated discussion in the scientific community. The resolution is so poor that it's almost impossible to draw reliable scientific conclusions from such limited data. One expert, expressing frustration with the image quality, described it as looking like it was filmed with a potato, making the photo more of a discussion point than valuable experimental data that could advance our understanding of 3I Atlas. NASA faces increasing pressure to release its own observations of the mysterious object. A US Congresswoman took the unusual step of writing directly to NASA, formally requesting the release of image data from 3I Atlas captured by American space assets. The agency's response has created controversy, as NASA stated it would only release the information once the US government shutdown ends. This answer has left the public indignant, particularly as many believe the agency possesses far superior imagery that could answer critical questions about the object's nature. Observers and researchers believe that high-resolution images from NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera, could provide crucial data to better determine the size, shape, and composition of 3I Atlas. The HiRISE camera is capable of capturing details as small as a dinner table from Mars orbit, making it potentially the best instrument currently in position to observe the interstellar visitor. Yet these images remain unreleased, adding to the frustration of the global scientific community eager for better data. The international astronomical community continues to wait for these high-resolution images, recognizing that they could provide breakthrough insights into the nature of interstellar objects. Some pessimistic opinions suggest that even the NASA images may not be much different from what China released, given the small size and distance of 3I Atlas. However, most experts maintain hope that American instruments, with their proven track record of capturing detailed imagery of small objects in space, will provide the clarity needed for meaningful analysis. The best hope for detailed observations now lies in getting new data from the Hubble Space Telescope and the James Webb Space Telescope, both of which are capable of capturing detailed images and spectra of the object. These space-based observatories, operating above Earth's atmosphere, can achieve resolutions and sensitivity levels impossible from ground-based telescopes. The challenge is securing observation time on these heavily scheduled instruments, as they must balance studying 3I Atlas with their many other scientific objectives. The latest image of 3I Atlas, taken on November 5th by an observatory in Spain, adds another piece to this cosmic puzzle. The image clearly shows the sun pointing in one direction, with a faint tip of what appears to be 3I Atlas's tail extending in the opposite direction, following the expected anti-solar direction for cometary tails. However, the color difference and poor contrast in the image make it nearly impossible to determine the exact size or length of the tail, leaving researchers to estimate based on incomplete visual data. What's most surprising about these recent observations is that 3I Atlas has remained remarkably unchanged despite experiencing strong solar wind and intense radiation as it passed perihelion, the closest point in its orbit to the Sun. Typical comets show dramatic changes during perihelion passage, with increased outgassing, brightening, and tail development. Yet 3I Atlas showed no signs of strong evaporation, no long tails extending millions of kilometers, and no eruptions of material from its surface. The object continues to defy all expectations established by decades of observing traditional comet models. NASA completed the latest orbital and gravity acceleration calculations of 3I Atlas on November 5th, using sophisticated computer models that account for all known gravitational influences in the solar system. The team compared these new calculations with data from November 2nd and 3, captured right around the object's perihelion passage. The results revealed something unexpected that has orbital dynamicists reconsidering their models. The calculations showed that 3I Atlas's gravity acceleration was significantly lower than initially predicted by standard models. This means the object didn't experience any major orbital deviations as it approached the Sun, a finding that contrasts sharply with observations of most common comets. Regular comets are often pushed slightly off course by jets of gas and dust released when solar heating causes ices to sublimate. This non-gravitational acceleration is a well-documented phenomenon in cometary science, yet 3I Atlas shows almost none of it. This unusual orbital stability raises fundamental questions about the object's composition and structure. Why is 3I Atlas so strangely stable in the harsh environment of space near the Sun? Is it made mostly of metal and rock, more similar to an asteroid than a traditional comet? Or does it harbour a previously undocumented physical mechanism that prevents the outgassing typically seen in comets? These questions are driving new theoretical work as scientists struggle to explain the observations. Solar activity during this period adds another layer of complexity to these observations. Since October 21st, a series of powerful solar storms have been observed emanating from our star, with many appearing to head directly toward 3I Atlas. Giant sunspots on the opposite side of Earth from our current viewing position have been erupting violently, sending streams of charged particles racing through the inner solar system at speeds of hundreds of kilometers per second. Some observers have suggested that this increased solar activity may be related to the presence of object A6 Lemon, which is currently moving close to the area where these solar storms originate. While most scientists are skeptical of any causal connection between comets and solar activity, the timing has prompted renewed examination of possible correlations between the positions of solar system objects and the Sun's behavior. When astronomers adjust their 3D models of the solar system to examine these relationships, a remarkable alignment becomes apparent. Earth, the Sun, and Lemon appear almost in a straight line at the exact moment when the observed sunspots are directing their emissions toward that region of space. This geometric arrangement was still evident on November 5th, creating what some scientists describe as a giant axis of energy extending between the Sun and Lemon. According to detailed simulations run on supercomputers, as Lemon approaches its own perihelion, it will once again align with the Sun and Earth in a similar configuration. This recurring alignment increases the statistical likelihood that sunspots will continue to emit powerful bursts of radiation in this direction for several more days or weeks. Scientists predict that solar activity may remain elevated for many days to come, potentially due to what they term the resonance effect of this rare alignment. The impact of this solar activity on Earth has already been significant. In just the past few days, our planet experienced a G3 geomagnetic storm, a moderate to strong disturbance that caused notable fluctuations in the planet's magnetic field. These storms can affect satellite operations, radio communications, and even power grids in extreme cases. Aurora displays were visible much farther south than usual, delighting skywatchers but concerning those responsible for maintaining technological infrastructure. Experts monitoring space weather warn that within the next 12 hours from the time of these observations, another even more intense storm could occur. The timing of this predicted storm coincides remarkably with Borisov's current position, as the object is moving very close to Earth, following an orbit that brings it near the orbital path of Venus. This coincidence of position has led many researchers to question whether there could be any connection between interstellar objects and the sudden increase in solar activity, though mainstream science sees no physical mechanism for such a relationship. The Minor Planet Electronic Circular, managed by the International Astronomical Union, has become the central clearinghouse for observations of C 2025 V1 Borisov. This database shows particular attention being paid to the object's unusual characteristics. Since its discovery, Borisov has generated 10 formal observation reports from astronomers around the world, each adding details to our understanding of its properties and behavior. The first report came from Borisov himself, who owns and operates an advanced telescope system specifically designed for detecting faint moving objects. His initial observation showed no cometary tail whatsoever, just a point source of light moving against the background stars. Most subsequent observations from other astronomers confirmed this tailless appearance, though with some interesting variations in what was detected. Only 2 reports out of the 10 recorded any sign of a faint tail, with measurements ranging between 50 and 72 arc-seconds long. However, these 2 observations were quite different from each other and carried significant uncertainty in their measurements. The inconsistency suggests that any tail present is extremely faint and may be intermittent, appearing and disappearing based on factors we don't yet understand. From this accumulated data, astronomers have tentatively concluded that V1 Borisov has almost no tail, a characteristic it shares with 3I Atlas. The similarity is striking, as 3I Atlas, although positioned more distant from Earth, appears many times brighter than Borisov. These 2 objects are currently located almost on the same straight line when viewed from Earth in the constellation Virgo, creating what many astronomers acknowledge as a remarkable coincidence in their apparent positions. The Stellarium software has become an essential tool for astronomers, tracking the positions of 3I Atlas, C 2025 V1 Borisov, and C 2025 K1 Atlas in real time. The software uses NASA's precise ephemeris data, mathematical tables that give the positions of astronomical objects in the sky at given times. These calculations account for all known gravitational perturbations and allow predictions of where objects will appear with remarkable accuracy. At 6 a.m. on November 7th, astronomers set up detailed simulations with the atmosphere effects turned off for easier viewing of faint objects. At this specific time, the objects were positioned in the morning viewing area of the sky just before sunrise. This timing represents the ideal moment to spot them on star maps, as they're high enough above the horizon to minimize atmospheric distortion, but still visible in the darkening sky before dawn completely breaks. The simulation revealed that 3I Atlas appears in the constellation Virgo, having crossed the orbit of Venus just a few days earlier in its journey through the inner solar system. This orbital crossing is significant because it means the object has moved from outside Venus's orbit to inside it, bringing it into the region where terrestrial planets dominate. The crossing occurred smoothly, with no detected changes in the object's trajectory or brightness. Nearby in the sky, C 2025 V1 Borisov appears almost identical to Atlas when viewed from Earth, making the two objects seem very close to each other despite their actual separation in three-dimensional space. This is a perspective effect, similar to how two aircraft at different altitudes can appear to nearly collide when viewed from the ground, even though they're safely separated. C. 2025 K1 Atlas occupies its position in the constellation Leo, completing this special triangle of space between the two major constellations. An intriguing hypothesis has emerged from some researchers studying these orbital configurations. They suggest that if a smaller object were launched or ejected from 3I Atlas toward Earth, its observed characteristics would match Borisov's profile remarkably well. The object would be dim due to its small size, lack a significant tail due to its composition or structure, and follow a trajectory that brings it between the parent object and Earth. While this remains pure speculation and is not confirmed by any direct evidence, the alignment and timing of the two interstellar objects have put the Virgo region of sky in the spotlight of intensive astronomical observation. Some analysts examining this data argue that we shouldn't rush to label every interstellar object as a comet, as our current models may not be adequate to describe their true nature. The behavior of both 3I Atlas and Borisov suggests they might represent a class of objects different from anything in our solar system's inventory. This doesn't mean they're signs of alien life or mysterious technology, as some sensationalists have suggested, but it does indicate the universe is sending us signals that force us to look at our theories with a more open mind. Several researchers have likened these observations to simulation testing, as if the universe is helping humanity prepare for situations that previously only existed in theoretical models. The rapid succession of interstellar object discoveries, from Oumuamua to 2I Borisov to 3 Atlas, and now this new Borisov object, suggests we're entering an era where such detections will become more common. Each discovery refines our understanding and challenges our assumptions about what exists beyond our solar system. The question of 3I Atlas's composition remains central to understanding its bizarre behavior. Is it made mostly of metal and rock, making it more similar to an asteroid than a traditional comet? This would explain its resistance to solar heating and lack of significant outgassing. Or does it harbor a previously undocumented physical mechanism, perhaps a surface coating or internal structure that prevents the sublimation of ices even under intense solar radiation? Although there's no definitive answer to these questions yet, astronomers across the globe agree that 3I Atlas is challenging all current understanding of interstellar comets. The object has demonstrated characteristics that don't fit neatly into any existing category of solar system objects. It moves at high speeds characteristic of interstellar trajectories, endures the energy storms of the Sun without showing expected changes, produces no significant tail and no observed eruptions, but still maintains a brightness that makes it visible to our instruments.